Assalamu alaikum shabab. Inshallah today we'll continue from where we started last time. Last time we talk about different topic. We just spoke about continue about the engine type, the engine. We continue our talk about engine type and part and the classification. We continue our talk about the engine part last time. We talk about the cylinder head, about the engine block itself, and about the crankcase, which is the lower part of the engine. And then we talk about the auxiliary system, including the fuel circuit, oil circuit, cooling water circuit. All of this we talk about it last time. Clutch, drive train, exhaust system, intake air manifold. Just to mention all of this and the function of each component inside the engine. Also, we give an insight about the engine terminology, the engine bore, which is the diameter of the piston, the stroke is the distance that the piston travel from the bottom lead center, which is the lowest point inside the cylinder, up to the top dead center, and we define the displacement volume. When we multiply it for one cylinder by the number of cylinders for a given engine, we get what we call actually the cubic capacity or the engine CC, as you know in case of cars. We talk about the configuration of the engine. It can be configured in line, U shape. We talk about the V shape in case of heavy duty engine, and W shape, or what we call the double V engine, the H engine, and in case of super also we have what we call actually the flat boxer or the flat engine. We have two opposite straight bank, inline bank of cylinder opposite to each other, and they are forming actually one engine. We talk also about the special case of internal combustion engine, which is the Wankel rotary engine. We have a rotor here instead of the piston, and this actually rotary engine, the rotor divides the combustion chamber into three parts. That means actually for each one revolution we'll have actually 3 power pulses of this engine, so the engine is very powerful. But you can see here we have a centric rotor. This centric rotor is connected to the central crankshaft through a gear, and this actually results in a lot of wear within the system, and it requires actually a special lubrication system. Also, we have a cooling water circuit around the system. In some cases, we may use 2 spark plugs in order to improve the combustion process. But as you can see, there is leakage problem also within the system and sealing within the system. That's why it is limited in application. However, it is applied in some engine like Mazda RX-8. This is a double rotor engine that has been used. But it has very limited application in cars. Today also we continue our talk, which is extended much about the introducing to the internal combustion engine. Here we are repeating the difference between a spark ignition engine and the diesel engine. Spark ignition, we have the charge to the engine is air plus fuel, and this air plus fuel is just being sucked inside the cylinder while the piston is moving down. We call it the intake stroke. Then it is compressed, and by the end of the compression stroke, we have to start the combustion using spark ignition. Using a spark ignition system, and that's why in case of gasoline engine we should have an ignition system to generate a spark inside the cylinder. Then we can initiate the combustion, then we can have the power stroke, and later we can get the exhaust stroke, and then we can repeat as a cycle in case of the four-stroke engine. For the fuel injection system in the gasoline engine, it started actually with the carburetor injection system, which is a kind of mechanical system that depends on creating a vacuum within the fuel flow rate, and this vacuum just sucks some fuel from the fuel tank. This system was not effective at all because actually it can just consume excess amount of fuel, so the fuel consumption is very high in this system. So the system has been converted to a more reliable system. It has moved to Motronic injection system, in which the ignition is mechanical and also the injection system is mechanical. But in this case, we have fuel injector in order to inject the fuel, and then we move to the electronic system system, injection system, in which the electronic, the fuel injection is electronic and the ignition is mechanical. And then we have moved to the Motronic injection system, in which injection of the fuel is electronic through the control from the electronic control unit, and also the ignition is also electronic in case of Motronic. Even the Motronic system has different version, ME Motronic, and at the end, actually in the year 2000, it has been invented the MED Motronic, which is the gasoline injection, but we have it is direct injection. In this case, we call it gasoline direct injection. In this case, we inject the gasoline fuel instead of upstream of the intake valve. We directly inject it inside the cylinder. This is actually in order to be able to raise the compression ratio of the gasoline engine and increase its power, and also in order to improve the combustion at part load, so that it can burn actually less amount of fuel in a bigger amount of air. We call it actually lean combustion. Lean combustion, that means we have much air that is more than actually the necessary amount of air to complete the combustion. If we have more air, we call it lean combustion. But if we have less amount of fuel, that is actually that is theoretically can burn actually the fuel, less amount of air that can actually theoretically burn the fuel, that means we have excess fuel. So we call it rich combustion. Rich combustion means we have fuel, but we don't have enough amount of air. Lean combustion, that means we have more air, but we have less amount of fuel. Okay, and this is يعني the idea شباب of injection system, and based on that we asked it to just prepare a presentation about the different. I just asked you about the Motronic fuel injection system, in which the injection of the fuel and the ignition system are electronic. Just to give us an idea about the component of this fuel injection system, starting from the fuel pump until the fuel reaches the injector, and how we can control the amount of fuel injected to the system. Also, we asked another group just to give us a presentation, talk about the ignition systems, the different kind of ignition system. As I told you, we have the conventional coil ignition system, we have the transistorized ignition, we have the semiconductor ignition system, and finally we have the distributorless ignition system, in which we have an ignition coil and separate ignition system for each cylinder inside the engine. Just we need to look at those components of the ignition system and the difference between both of them, between all of them. Also, we talk about the fuel injection in diesel engine. In gasoline engine, actually, we control the amount of air through the control of the throttle valve opening, which is connected to the accelerator lever. So we control the amount of air. And in this case, the fuel is actually calculated based on the electronic control unit, both based on the required load, the throttle valve opening, and also based on the required engine speed, we can decide about the amount of fuel to be injected. But in case of diesel engine, the accelerator pedal is not connected to a throttle valve. It is connected actually to the fuel pump, and the fuel pump just to control actually the amount of fuel to be injected to the system, and we don't have throttle valve in case of diesel engine. So in case of gasoline engine, we control the amount of air through the throttle valve, which is connected to the accelerator pedal. And in case of diesel engine, the accelerator pedal is connected to the fuel pump. So it controls the amount of fuel. Okay, and that's why also we asked here that we cannot cover all of the topics. Those are actually big system. We have different fuel injection system for diesel. We have the inline system, inline pump system. We have the common rail system, and then we have the distributor pump injection system for the diesel engine. Just to want to see actually those system, and you can give us idea actually about how the fuel is injected and metered to the engine depending on the engine load and the engine speed. Okay, here just I can give you an idea about the throttle valve in case of gasoline engine. If this is this is the engine. Here actually we have the piston, and this is the intake valve, and here we have the exhaust valve. In case of gasoline engine, we should have here actually spark plug. If you look here at the intake manifold upstream of the intake valve, here in case of gasoline engine, we have actually the fuel injector upstream of the intake valve. But upstream of the fuel injector, we have here actually what we call the throttle the throttle valve. The throttle valve control actually the amount of air coming into the system. So the throttle valve controls the amount of air. This throttle valve is just connected to the accelerator pedal. So when you are just sitting in your car, here it is connected to the accelerator pedal, and here you are just standing, okay? And then you can just press the accelerator pedal. It is connected to a wire, and in all the gasoline injection system, it is connected through a wire to the throttle valve, so that it can open the throttle valve. If you need higher speed, it will press the throttle valve to have actually higher opening, to have more amount of air. Then the electronic control unit measure actually the amount of air based on actually the angle rotated by the throttle valve. Then it can decide about the time in which it will supply current to the solenoid injector to supply the fuel. It will decide actually about the time. As this time is elongated, then more fuel can be injected. Okay, if we need less fuel, then the time during which actually the electric current is supplied to the fuel injector will be reduced in this case. Then we have, once the intake valve open, we'll have fuel plus air here. But in case this is in case of gasoline engine, when we have gasoline engine, okay, or spark ignition engine. In case of diesel engine, the accelerator pedal here under your leg while driving is connected to the fuel pump. So it decides actually about the amount of fuel to be actually introduced to the engine. And in case of diesel engine, we don't have throttle valve, okay? So in case of diesel engine, we control the fuel. In case of gasoline, we control the amount of air to the engine. Type self gasoline fuel, these are the fuels that can be used in the gasoline engine. We can have the gasoline, the basic gasoline fuel, which is octane, C8H18. We can use also compressed natural gas in gasoline engine. We can have some modification to the intake system, but it can be actually used in gasoline engine. Ethanol or alcohol also, like ethanol, bioethanol, methanol. Bioethanol is the ethanol actually from biodegradable sources or renewable sources. It can use also hydrogen. It can use liquefied petroleum gas, which is the gas actually which is used actually at homes in the bottle for stoves, which is used actually in cooking and all of that. It is a mixture of propane plus butane. Some also synthetic fuel like nitromethane can also be used in the gasoline engine. So the gasoline engine offer actually a range of fuel to be used. In case, unlike the case of diesel engine, which is limited to the dodecane, which is diesel fuel, C12H26, and also some cases we can use biofuel. Biofuel is a fuel from renewable sources, which is generated through the transesterification process of oil. Those oil can be edible oil or non-edible oil. Edible, we can use the waste oil from the restaurant and all of that. We can just purify them, and then we can have the transesterification process, and it is a chemical reaction with methanol or ethanol, any alcohol, any of them. In the presence of catalyst, it can produce actually methyl ester or ethyl ester. Methyl ester or ethyl ester, we call it the biofuel. It is not very close to in chemical composition like the diesel, but we just call it biofuel because its combustion characteristics is close to the diesel more than the case of gasoline, and it can be used in the diesel engine. So the process will result in methyl ester or ethyl ester, which is a biofuel, plus glycerin. Glycerin, which is the basic component of manufacturing the soap. It's a very pure material and also expensive also. So biodiesel can be produced from non-edible oil that cannot be used in our food, like actually Jatropha oil. Jatropha oil is a kind of a tree. It looks like olive, but it is not. It produces actually oil, but actually it can be irrigated using salty water, and it can grow actually in the desert. So under severe condition, it can work. It can grow actually, and then we can generate biofuel using the oil that we cannot use actually in cooking, but we can produce biofuel. Biofuel is fuel from biosources that are biodegradable. Due to the combustion, it will result in carbon dioxide. This carbon dioxide can be absorbed by plant in the photosynthesis process. Okay, but actually the carbon dioxide produced from the normal diesel fuel, from the fossil fuel, it cannot be actually recycled in the photosynthesis process of the plant. So this is actually a fuel, clean fuel, that can be actually from renewable sources and it is biodegradable, it cannot result actually in global warming like the case of carbon dioxide produced from the fossil fuel. The main difference between spark ignition and gasoline, as we said, the spark ignition engine cannot be operated under higher compression ratio. We'll talk about this. Gasoline engine work on Otto cycle. As we said, cycle from taking the fuel until the exhaust, we call it this cycle. Cycle may consist of 4-stroke or 2-stroke. But the main difference between gasoline and diesel is that the combustion in gasoline in the Otto cycle occurs at constant volume, while the piston is instantaneous combustion at a given moment of the piston movement. But in case of diesel engines, the combustion is a little bit extended because the fuel is injected at the end of compression stroke, so it needs some time to mix and some time to burn, unlike the case of gasoline engines. So in case of diesel engines, the combustion takes place under constant pressure. In case of diesel cycle, diesel cycle for ideal diesel engine, not the actual one, but in reality, actually, the diesel engine work on the dual cycle, in which part of the combustion takes place at constant volume, instantaneous, and the other part of combustion it completes actually while the piston movement under constant pressure. Fuel having higher self-ignition temperature in case of gasoline, of course, because we don't want actually the gasoline fuel to self-ignite because we have a spark plug. In case of diesel, it have actually lower self-ignition temperature. Lower self-ignition temperature, we don't need the fuel to in case of diesel engine, it has a lower self-ignition temperature because just it depends on the self-ignition. We need the fuel to self-ignite. In case of air, the charge here to the gasoline engine is air plus fuel, but the charge in diesel engine is only air, and the fuel is just injected at the end of the compression stroke. Here, as I told you, we control the system, the engine, we call it quantity control. Quantity control because we control the amount of air. We said here, throttle valve based on the accelerator pedal press, it can control the opening for the throttle valve, so we control the amount of air. So that's why we call it actually the quantity control. And based on that, we decide about the amount of fuel. So in most of the cases, for the gasoline engine, we keep the air-to-fuel ratio is almost fixed at all loads. Okay, so we measure the amount of air, then we inject the amount of fuel to keep the air-to-fuel ratio within a fixed range. But in case of diesel engine, we call it quality control because in this case, in case of diesel, we don't have throttle valve, just the accelerator pedal is connected to the fuel pump to control the amount of fuel injected. And in this case, we don't control the amount of air. So whatever air is coming in, we just inject the amount of fuel depending on the load. That means the air-to-fuel ratio will be different in this case. And that's why we call it the quality control. Depending on the load, we decide about the amount of fuel. But here, the air-to-fuel ratio is almost fixed. This is a spark ignited, and this is actually self-ignited in case of compression ignition. The compression ratio, one of the most important parameters, is the compression ratio in case of gasoline engine cannot be raised more than 10.5 because raising the compression ratio will result actually in self-ignition of the fuel. Raising the compression ratio, compression ratio, this is the bottom dead center, and this is the top dead center, the highest point, and here actually between, this is the volume, actually we call it the displacement volume, and here's the small volume, we call it the clearance volume. The compression ratio is the ratio between the cylinder volume divided by the clearance volume. Cylinder volume, which is the displacement volume plus the clearance volume divided by the clearance volume. So the total cylinder volume divided by the clearance volume will give us the compression ratio. But what is the compression ratio? It gives us indication about the pressure at the end of the compression stroke. Pressure range. So if we are able to reduce the clearance volume a little bit much, that means we will be compressing the air and the fuel in case of compression stroke to a very small volume. That means in this case the pressure will be high. So as the clearance volume reduce, the compression ratio will be higher, and the pressure inside the cylinder at the end will be higher in this case. But in case of gasoline engine, we cannot go for higher compression ratio. because in this case we cannot approach a very high pressure. So as the pressure increase during the compression stroke while the piston is moving up, the temperature as well will be increased. But if it is exceeding actually the self-ignition temperature of the fuel, then before the piston reach the top dead center while the compression stroke, the fuel may self-ignite at some point close to the corner or something, because close to the corner the gases gets hotter in this case. So this will be self-ignition, explosion. And after some time while the piston is moving, we'll have self-ignition in another point, and self-ignition in a third point, and the spark will initiate the combustion as well. So it is a lot of explosion during the compression stroke. So this is what we call ya shabab as the engine knock. You will hear actually the engine is knocking, like actually knocking a door. It is a kind of noise of the engine, and it is very dangerous. Because in this case, when you start the self-ignition while the piston is moving up, some heat, we call it Q, heat will be released. And in this case, the pressure inside the piston will be released much. So the piston, this heat release will try to press the piston down. But the piston is moving up. This piston is connected to the crankshaft, and the crankshaft is rotated, should be moving up. So in this case, we lose part of the heat shabab in the resistance during the compression stroke. Then it will be small portion of this heat will be used during the expansion or the power stroke. So it causes actually power loss of the engine. So in case of gasoline engine, we cannot raise the compression ratio. But in case of diesel engine, we can raise the compression ratio, as actually the charge through the intake valve to the engine is only air. We don't have fuel to self-ignite. Just as the fuel is injected at the end of the compression stroke. That's why we can go for higher compression ratio. And as we said, shabab, the efficiency for the gasoline engine, as we can go for higher compression ratio, that means higher pressure by the end of the compression stroke. That means we can get higher power of the engine during the expansion stroke. Higher powers mean high efficiency. So the diesel engine are much efficient than the gasoline engine because it can go for higher compression ratio. Okay, but why gasoline engine are not actually widely used? So you will see everywhere actually gasoline engine, but diesel are limited to the heavy duty trucks and all of that. Why? Because the diesel engine, it depends on injecting the fuel at the end of the compression stroke. Once injecting this fuel needs some time to mix with air and to start the combustion. So it needs some time. If we are working here at higher RPM of the crankshaft, the piston will be moving up and down very fast. So in this case, the time for the combustion will be reduced. That means we have incomplete combustion. So we will have actually power loss, significant power loss at high engine RPM. That means actually diesel fuel are not preferred actually to have higher speed. But actually most of the people just want the car to go for higher speed, whatever the efficiency, we don't care. So in this case, that's why the gasoline engine are usually actually spread, because gasoline engine we have a spark plug that can initiate the combustion, so that we can go for higher RPM in this case. In case of diesel engine, gasoline engine, we have part load efficiency is very low, because as we said, we control the amount of air and then we can inject the fuel. Then we can control the air to fuel ratio fixing at all load. But in case of part load, we don't need much fuel. Just unlike the case of full load, we do need actually more fuel. But in case of part load, it keeps also the fuel to oil ratio fixed. That means the system is consuming more fuel at part load. But in case of diesel engine, it controls the amount of fuel depending on the load. So it is much efficient in the fuel economy in this case. But that, ya shabab, was in the early version of the spark ignition engine in the cars, specifically in case of cars. In the old version, they used to have this injector inside, actually just fix it to the throttle valve. We call it single point injection. And then the flow of air can be directly to this cylinder through the intake manifold, or to the other cylinder, or to the third cylinder, or the fourth cylinder. Okay, depending on actually which intake valve is opened and depending on the firing order. So have only one throttle valve in the intake manifold with the fuel injector, and actually this can be distributed to different cylinders depending on which intake valve is open. It will take the charge. If this open, it will take the charge, and we have only single fuel injector. And this result in bad fuel economy at part load, because only we have single fuel injectors that can be actually deliver the fuel to all cylinder, and it can keep the fuel to air ratio fixed. It does not change with the load. But in case of modern engines, they said we can use actually multi-point fuel injection system in which we have injector for each cylinder. And the amount of fuel for each cylinder, and so for this injector will be decided actually about the amount of air in this case. And in case of part load at low engine RPM, low engine speed, in this case the electronic control unit will inject less amount of fuel. And this is actually what we call multi-point fuel injection system. The cost, other difference, the cost of petrol is higher than the cost of diesel. At least we have additional system like the ignition system, which we don't need in case of diesel, so that which should result in higher cost of gasoline engine, and also the fuel economy in gasoline engine is a little bit higher than diesel, and also the efficiency of gasoline is less than the diesel, so that should result in higher cost. Noise and vibration are less because the less engine weight, but in case of diesel, if you have to increase the compression ratio, we have to actually add more, to strengthen actually the wall of the cylinder by adding more material so that it can withstand this high pressure. So in this case, the engine weight gets heavier in this case as we increase the compression ratio, because the pressure will be higher and we have to put materials that can actually withstand this pressure. The emissions of engine emission in case of incomplete combustion, the carbon will be converted to carbon monoxide instead of carbon dioxide. We have NOx in case of air, we burn with air, which is O2 plus N2. N2 just dissociate at high temperature to N plus N, and each N will combine with oxygen to create NO and NO2, which we call them as NOx emission. And we have unburned hydrocarbon in case of incomplete combustion. We can have unburned hydrocarbon. In case of diesel, as the fuel is heavier, we have actually the chemical composition is much heavier than the case of a gasoline engine. That may result actually also in some soot. And that's why in the fuel injector, in case of diesel engine, can be replaced actually much faster than the case of fuel injector in gasoline engine. So light fuel can be used. Here actually heavy fuel can be used. Some green fuel can be applied like H2 biofuel. All of this are available, but in case of diesel engines, the amount of fuel for the diesel engine fuel types are limited. Here is application. You can see here we have, depending on the spark ignition or diesel engine, usually the gasoline engine are used whenever we need high speed, and also in light duty engine. But in case of heavy duty engine, like when we have railway, we are using actually in a train or something, or small, or in case of boat and ships, all of this actually we just need the efficiency and we need higher power. So in this case, we use diesel engine in heavy duty engine, but in all the small duty to medium duty, we can use actually just the spark ignition as a spark ignition engine. Okay, you can look here either spark or diesel engine, depending on the application, and it can be air-cooled. Air-cooled is used in a small engine, like the motorcycle. You can use air cooling for engine cooling, but in most of the cases, we have the engine is water-cooled. Type the 4-stroke versus the 2-stroke engine. 4-stroke, we said this more than once. 4-stroke, the engine complete one cycle from the intake and when we take the air plus fuel until actually we exhaust the exhaust gases. This is called actually as one cycle. One cycle, the piston will be moving down first for the intake stroke to take the air plus fuel, and then the air plus fuel will be compressed, and at the end of the compression we'll have the spark initiating the combustion. Then we can have the power stroke. Piston will be moving down from the top center to the bottom center, and then the piston will be moving up in this case to exhaust the gases. This is one cycle is completed in 4 strokes. The 4 strokes are the intake stroke or the suction stroke, compression, power stroke, and we have the exhaust stroke. Then the cycle is repeated. The cycle is repeated back. 4 stroke can work for spark ignition, and also it can work actually for compression ignition. 4-stroke engine can also work naturally aspirated, like in our case, we are naturally aspirating air we don't have this is, we call it natural aspiration, or it can be turbocharged or supercharged. Turbocharged or supercharged, we should have a compressor in this case. We just have a compressor which takes the air and compresses this air to higher pressure. Then we can increase actually M lot of air, the mass flow rate of air to the engine air, and the outlet of the compressor is connected to the intake manifold of the system. In this case, this compressor is either driven by part of the crankshaft power, we call it supercharged. The compressor is driven by part of the power produced by the crankshaft. Or in case of turbocharged, we can just take the exhaust gases here. The exhaust gases actually will be driving a fan with blades air. Okay, so the exhaust gases will hit the blades and it will rotate the shaft. We can generate shaft power. This shaft power can be connected to the compressor to drive the compressor, to compress the air. We call it turbocharged in this case. Inshallah, we will have a separate chapter talking about turbocharging and supercharging. But the idea here is to use the compressor in order to raise the pressure of the air to increase the amount of air to the engine. Then we can increase the amount of fuel. So fuel plus air are increased, then we can generate more power of the engine. We call it turbocharged or supercharged in this case. Type here is here are actually the 4 strokes. You can look at the 4 stroke. We have, if the piston is starting at the top dead center, then once the piston start moving down, then in this case the piston the piston will be moving, start moving down. The intake valve will open to have air plus fuel mixture get inside the cylinder. Then the piston will reverse the movement, and in this case the intake and the exhaust valve will be closed. Both valves are closed. The piston is moving up to compress the air plus fuel. Before the end of the compression stroke, spark will be initiated using the spark plug to start the combustion process. Then the heat will be released and the piston will be moved down to generate actually shaft power, or during the power, we call it the power stroke in this case. Then the piston will be moving up back in order actually the exhaust valve will be open and the exhaust gases will be leaving the system in this case. If you look at the pressure crank angle diagram, here is the pressure crank angle diagram. If you look here, before at the top dead center, the piston is moving down. Then until it reaches the bottom dead center, let's look here itself. I will just show you how we can just translate the crank, the piston movement into crankshaft angle. What is the relation between this movement and how we can draw it in terms of crankshaft revolution? Here it is. If we have, this is our piston and this is the cylinder and this is the intake valve, and here we have the exhaust valve, and here at the middle we have the spark plug. This is the piston. Let's assume this piston is just existing at the top dead center, and this is let's say this is the bottom dead center. This piston is connected to the crankshaft, which should be actually rotating through the connecting rod. If the piston is here at the top dead center, so this connecting rod is just vertical, and the piston is at the top dead center in this case. When the piston starts moving down during the intake stroke, when it completes actually one stroke movement from the top dead center to the bottom dead center, the crankshaft will be rotating half degree until it reaches the bottom dead center. So here is the bottom dead center. Half degree shabab means we have what? 180 degree in this case. This is half revolution. But when the piston starts moving up from the bottom dead center to the top dead center, it will be another half revolution, which is 180 degree. 180 plus 180, that means actually those are 360 degree, and you will get back to the same point, which is 0 degree or 360 degree. So this is the intake stroke, during the intake stroke, and this is during the compression stroke. Then we'll have another stroke. The piston will be moving after initiating the combustion. We will have the expansion stroke. the piston is expanding from the top dead center to the bottom dead center during the power stroke. This is also half revolution, 180 degree. And then from the bottom dead center, the piston will be moving up again during actually the exhaust stroke. So this is the exhaust stroke, and this is also during 180 degree to get back again to the top dead center in this case. Okay, and this is how we can just translate the piston movement from the top dead center to the bottom dead center in terms of degree. So each travel for each stroke movement, we should have actually half revolution, which is 180 degree in this case. Okay, type here you can just see here piston is here at 360 degree, which is at the top dead center. When it is moving to the bottom dead center while the suction stroke, this is the pressure, the blue line is the pressure. Almost during the suction stroke, the pressure is almost constant, the intake valve is open, and the pressure is almost very close to the atmospheric pressure. Once the piston reaches the bottom dead center and starts the compression stroke, the pressure will be raised. Pressure will almost be the maximum at the end of the compression stroke. Then we can have power stroke until the piston reach the bottom dead center. Then we should have the exhaust stroke, which is almost also under constant pressure, which is very close to the atmospheric pressure. Because the exhaust valve, once it opens, it is subject to the atmosphere, so the pressure is reduced to the atmospheric pressure. Here is the temperature. Temperature gets down because of the incoming fresh air during the intake stroke. Then the temperature starts rising during the compression stroke due to the rise of pressure. And during the expansion, the temperature will be reduced. And then during the exhaust stroke, almost the temperature will be fixed in this case. Okay. We have some advantages of the four-stroke engine. The four-stroke engine is have a dedicated lubrication system that makes the engine actually wear resistance. It has better efficiency than the two-stroke engine because in case of two-stroke engine we don't have valve. Just we have side opening, one side opening here as the intake port, and we have one side opening from the other side as the exhaust port. And usually when the intake port, the inlet fuel plus air are coming in, we have also an overlap period in which both ports are open to each other, opposite to each other, so some fuel actually is just exhausting without burning. So one of the drawbacks of the two-stroke engine is its lower efficiency due to actually the higher consumption rate of the fuel, unlike the case of four-stroke engine in which we have valves and the amount of fuel is precisely actually controlled. Also, it results in less pollution, as we should have some fuel is like the case of motorcycle. Usually, if you are close to the motorcycle, you will smell some fuel is going from the exhaust because actually it does not result in complete combustion of the fuel. Some fuel is just escape during the overlap period in which we have the intake port and the exhaust port are opened at the same time. So that's why its efficiency is low and it results in higher emissions. That is in the case of two-stroke, unlike the case of four-stroke. Also, it used where the engine four-stroke is used actually when the engine efficiency is important, but two-stroke engine is used actually when we need more power. Because two-stroke engine, we combine the compression plus the intake in one stroke and the expansion plus exhaust in another stroke. That means we should have power for each one revolution of the crankshaft. But in case of four-stroke, we have one power stroke for each two revolution of the crankshaft. That means theoretically, the two-stroke engine can reduce double of the power of the four-stroke engine. That means the two-stroke engine is more powerful, but it can consume more fuel, so it is less efficient. The drawback of four-stroke engine, it is complicated, cost construction, we have valves and all of this. Compared to the two-stroke, and it should work in the horizontal position due to the lubrication system. It cannot work actually in the vertical position. Type here is the two-stroke, شباب. As we said, two-stroke just to combine the compression plus intake in one stroke, and then the expansion plus exhaust in another stroke. If you look here, while the piston, first of all, piston is moving up. While the piston is moving up, look at the crank case here. Piston is moving up, so the intake port will be opened here, and the crankcase will be filled plus air, filled of air plus fuel. Then while the piston is moving up, we should start in this case the intake stroke plus the compression. So intake stroke, if you look here, air plus fuel will be going from the side here, beside of the piston, and during the compression stroke, this air plus fuel will be allowed to get inside the cylinder while the piston is moving up, and it will be compressed at the same time. And at the end of the compression, we should have the spark to initiate the combustion. After the spark, the piston will be moving down. Piston moving down will have expansion stroke, and while the piston is moving down, it will uncover the exhaust port so that we can have the exhaust at the end of the expansion stroke as well. So we combine both of them. But if you look at a given time, you will find the intake port and the exhaust port are open at the same time. That means some charge of air plus fuel can just actually have a short circuit and they can just escape without burning inside the engine in this case. Okay. And also, Shabab, in case of two-stroke engine, air plus fuel is introduced beside the piston. And the piston, in its side, we should have lubricating oil ring, and all of that. So the oil should be dropping here. But we have inside the crankcase, we have air plus fuel. That means some oil will be getting inside the cylinder and it will be burned. And it will result in excess amount of emission in this case. And that's why I told you in case of motorcycle, which is two-stroke engine, you will have some smell. This smell due to the fuel that is short-circuited without burning, and due to also the oil. The lubrication oil, part of it is burned inside the cylinder. So it results actually in different smell in case of two-stroke engine. And those are actually the main drawback of the two-stroke engine. Here also another something, Shabab, why we should introduce the air to the crankcase, air plus fuel. We call it actually crankcase scavenging. Because, Shabab, here when the fuel plus air is allowed to get inside the cylinder, it is during the compression stroke. So the pressure inside the cylinder should be a little bit high. If this air plus fuel is coming at atmospheric pressure, it will not be able to get inside the cylinder. So that's why we have to raise its pressure. So while the piston is moving down, it compresses the air plus fuel inside the crankcase. And then it can allow it to get the cylinder under high pressure in this case. We call it the crankcase scavenging. This helps, Shabab, air plus fuel to get inside the cylinder. And also it helps scavenging the exhaust gases, because while the piston is moving up, still we have some exhaust gases. So we have to force them to leave the engine. We call it crankcase scavenging. This is the cycle for the 4-stroke and the cycle also for the 2-stroke engine. We can just look at this cycle. For the case, let me just draw it as a cycle for the 4-stroke engine, or the 4-stroke cycle. We can look at it actually on the BZ diagram. The 4-stroke, that means actually we have 2-stroke. First of all, the piston is moving from the top dead center until it reaches actually the bottom dead center. It is just reciprocating in between. So let's start this cycle starting from point 1 for the 4-stroke when the piston at the bottom dead center. During actually at the beginning of the compression stroke. Starting compression, so the volume of the cylinder will be reduced in this case, and in this case the pressure will be raised in this case. The volume here, Shabab, when the piston is at the top dead center, the volume inside the cylinder should be the clearance volume. And the volume between the top dead center and the bottom dead center, we call it the displacement volume. While piston is moving during the compression stroke from 1 to 2, from the bottom dead center to the top dead center, pressure will be raised and the volume will be reduced of the gases in this case. So from 0 to 1, this is actually the compression stroke. And at point number 2, then we have at the end of the compression stroke, we should have the spark plug to initiate the combustion. The combustion actually in case of gasoline engine is instantaneous under constant volume from state 2 to state 3. Instantaneously when the piston is at the top dead center. So from 0 to 1, no, 0, this is from 1 to 2. Then from 2 to 3, this is actually the combustion process, instantaneous combustion under constant volume. Constant volume, that means the piston is not moving, just it is instantaneous. Once the piston reaches the top dead center, we start the combustion and end the combustion. Now the temperature from 2 to 3, and the pressure will be raised due to the heat release due to the combustion. Then the piston will be moving down from state 3 up to state 4. So from 3 to 4, this is actually the expansion, or we call it as the power stroke. So expansion or power stroke. Then at point 4, the piston is at the bottom dead center, the exhaust valve will open, and in this case the pressure will be reduced. Once the exhaust valve is open, it is subjected to the atmospheric air. So we'll have actually a drop in pressure throttling through actually the exhaust valve. So the pressure will be dropping instantaneously from 4 to 5, and when the piston is moving from the bottom dead center to the top dead center until it reaches point 6, then all of the gases will be exhausted in this case. So from 4 to 5 to 6, this is actually the exhaust stroke. Then the intake valve will open to have the intake stroke at point 6. Once the intake valve is opening and the piston is moving down, so in this case the pressure will drop inside the cylinder instantaneously from 6 to 7, and then the piston will be moving down from the top dead center to the bottom dead center until we reach point 1. Then we can repeat the compression stroke. So from 6 to 7 to 1, this is the intake stroke. Okay, and this is the cycle, the 4-stroke cycle, the cycle for a 4-stroke gasoline engine. In case when we have actually a 2-stroke engine, as we said, we combine the compression plus intake stroke in 1 stroke, and we have the exhaust plus the expansion are combined also in another stroke. So in case of 2-stroke engine, 2-stroke cycle, we can represent also the process on the PV diagram. This is the top dead center, and here we have the bottom dead center. Okay, so if the piston at the beginning here, let's say this is point 0. Okay, so from 0 to 1 at the beginning of compression stroke, we will have the suction from 0 to 1 while the piston is moving up. We will have suction of air plus fuel from the intake port. So from 0 to 1, this is the intake or the suction, while the piston is moving from the bottom dead center towards the top dead center. Then the intake port will be closing at point 1, and we will complete the compression stroke until we reach point 2. So from 1 to 2, we will have this is the compression. And then at point 2, the spark will be initiated. From 2 to 3, this is an instantaneous combustion. In case of gasoline engine, that will be the combustion process will be starting. And then we'll have 3 to 4, the piston will be moving down. This will be the expansion. And when the piston is moving down, in case of 2-stroke, it will uncover the exhaust port. So the exhaust port will be opening. Once it opens, subjected to the atmospheric pressure, the pressure will drop down here until it reaches actually the bottom dead center. And this from 4 to 0, that will be actually the exhaust stroke. So exhaust plus expansion are combined together, intake plus compression are combined together in 1 stroke. So this is suction from 0 to 1 and from 1 to 2. So during 1 stroke movement, from the bottom dead center to the bottom dead center, we have both of them, intake plus compression. And also during the reverse movement from the top to the bottom dead center, we have the expansion 3 to 4, and from 4 to 0, we have the exhaust stroke. Okay. This is the main difference between 4-stroke and the 2-stroke. So what about if you have the actual valve timing diagram? If we need the engine is running at low speed, then the intake valve will be opening the same opening like when the engine is working at high speed. So what is the difference in this case? At high speed, we just need more air plus fuel. So we need to extend the opening time for the intake valve. Unlike this, we need to extend actually the opening time for the exhaust valve in order actually to make sure all of the exhaust gases has left the engine. But actually, those intake and the exhaust valve, they are just connected to the camshaft. Here we have the camshaft and we have the cam which operates the intake and the exhaust valve. And this camshaft is connected to the crankshaft, which is running at half speed of the crankshaft. And we have fixed cam design. So that means the time for opening the intake valve and the exhaust valve will be fixed. We cannot change it depending on the load, depending on the engine speed. But actually there is a necessity that we need to do some change in the opening. We need to make this opening short in case actually when we have low speed of the engine, and we need to extend it for more time in case of high speed. You need actually more air plus fuel to have engine high speed in this case. And this is actually what we call as a valve timing mechanism for the engine, so that we can control the valve timing at higher and lower engine speed. This is a system actually invented by Honda. We call it actually the VTEC mechanism, the valve timing, variable valve timing mechanism. So at low engine speed, we have here this piston. First of all, this engine have 2 intake valve for the cylinder. That's why we have 2 intake valve here. So the intake valve are open through the camshaft, and those are cam, but we have 3 cams in this case. Okay, the outer 2 cams, they are actually smaller cam, and the inner one is a big cam. Okay, so at low speed, this inner cam, big cam, is just loose. This pin actually is just disengaged or disconnect actually the central cam. So the valve is opened using actually the outer 2 cams, and the valve lift in this case will be opened actually small lift. But in case of high engine speed, this pin, central pin valve here, due to the higher oil pressure at higher engine speed will just press this pin. You can see here, it can engage the central cam with the other 2 cams. Then in this case, the central cam will be the cam, you can look here, will be the cam that is opening the intake valve, and it will allow actually for more lift of the valve, and in this case more air will be coming into the system. You can check this YouTube video. You can just see actually the main component in your car. This is a Honda version car. You can just look at this video and see actually how this central cam is just opening the valve at the high engine speed, and the other smaller cams are opening the valve at lower engine speed. And that's why we have some terminology we call valve lead. Valve leads, that mean actually we open the valve earlier before the top dead center, like the intake valve. Valve lag, we close the valve after the bottom dead center. We close the intake valve after the bottom dead center to allow actually more charge to come into the system. And we have what's called the valve overlap. Valve overlap is the overlap period in which both the intake valve and the exhaust valve are open at the same time, to allow actually the air coming in to just discharge all, make sure that actually all of the exhaust gases have left the system, and this also allow for better pressing of the engine. The charge during the compression stroke, when we exhaust all of the exhaust gases, will be much better. We call it better pressing, and actually it will result also actually in better efficiency of the engine, and it will reduce the noise. We cannot open the intake valve, open the exhaust valve and close the intake valve at the same time at the top dead center. This will result actually in much noise as well in the system. Let's look at the valve timing diagram. Valve timing diagram for the case of four-stroke gasoline. Valve timing diagram is when the intake, the timing of opening and closing the intake and the exhaust valves. Okay. So this is the engine. We have actually, this is the intake valve, the exhaust valve, and this is the top dead center. We say this is the top dead center at which the connecting rod is just vertical here, and the piston is just as actually is at the top dead center. When the piston is moving down, this engine will be rotating actually half revolution until it reaches the bottom dead center. Half revolution, we have 180 degree in this case, and then it will be repeating during the compression stroke. Then we have expansion, and then we can have the exhaust stroke in this case. But let's represent this and see actually how, when actually the intake and the exhaust valve are opening and are closing with respect to the top dead center and the bottom dead center. So the valve timing diagram for four-stroke spark ignition engine. We have four-stroke spark ignition engine, and we want to see the valve timing diagram. So let's say if you have this as the top dead center at this point of the engine, and this is actually, this is the bottom dead center, top dead center and the bottom dead center. Usually, and this is the crankshaft, which is rotated. Usually the crankshaft, while the rotation, we open the intake valve is open before the piston reaches the top dead center while the exhaust stroke. So before we start the suction stroke and while being during the exhaust stroke, the intake valve will be opening a certain angle of the crankshaft. This angle, you can look here, it is about actually 15 degrees, in which the intake valve open before the piston reaches the top dead center while the exhaust stroke. So the intake valve open when the piston is moving up while the exhaust stroke, close to the end of the exhaust stroke, to make sure actually that we have a fresh charge of air that will discharge actually all of the exhaust gases to be forced to go through actually the exhaust valve. Then now we are at the top dead center and the piston will be moving down to have actually to suck the air plus fuel. So from here at the top dead center, intake valve is open. So this will be actually the intake stroke, in which actually the valve intake valve is open, and in this case the piston is moving down until we reach the bottom dead center. All of this we have the intake valve is open. Still the intake valve will be open during also during actually a small degrees after the bottom dead center during the compression stroke. So once the piston is at the bottom dead center, we should start the compression stroke, and the piston is moving up in this case. But still the intake valve is open to have more air to the engine, but actually it will be closing, intake valve will be closing few degrees, about actually 30 degrees. So the piston is here, then while it is moving during the compression, about 30 degrees here, the intake valve will be closing in this case. And then we'll continue the compression, stroke. So this is the compression, okay? Before the engine actually reach here, the top dead center but a given angle, so the combustion actually will be starting in this case. We should have a spark plug to initiate the combustion. So the combustion will be initiated here before the top dead center. Then the pressure and temperature will be increased in this case. The pressure should be the highest at the top dead center. Then we should have the expansion stroke. So this is actually the expansion stroke. The piston is moving from the top dead center to the bottom dead center. But before actually the piston reaches the bottom dead center, during the expansion stroke, the exhaust valve will be opening a little bit early before the bottom dead center to allow actually to have pressure, higher pressure actually, to make sure that the pressure inside the cylinder is a little bit high, so that actually it can force the exhaust gases to go outside. So while the piston during the expansion, it didn't reach the bottom dead center, so still the pressure is a little bit high at this point. We open the exhaust valve to make that there is a pressure difference between the cylinder and the atmospheric pressure, so that the exhaust gases can be leaving in this case. Okay. Then the exhaust valve is open, the piston will reach the bottom dead center, and then we'll have the exhaust stroke. This is the exhaust stroke. And then the exhaust valve, when the piston reaches the top dead center, still the exhaust valve is open. It will be closing after the top dead center. So the exhaust valve will be closing few degrees after actually the top dead center to make sure that all of the gases has been exhausted. But during the exhaust stroke, we will get back and the intake valve will be opening here, a given angle again to start the suction stroke and start a new cycle. So here the intake valve is open here before the top dead center, and still the exhaust valve is opening, and the exhaust valve will be closing after the top dead center. And the intake valve is still open. That means this period, Shabab, in which we have the intake valve and the exhaust valve are opened at the same time, we call it the overlap period, in which actually both intake valve and exhaust valve are opened at the same time to allow actually scavenging of the exhaust gases. All of the exhaust gases have left, make sure that it has left the engine, and it allow actually better breathing of the engine. Also, Shabab, we cannot open the exhaust valve at the bottom dead center. We cannot open the intake valve when the piston at the top dead center because the piston is moving. In this case, if the piston is at the top dead center and the valve is trying to open, you can just look here. if the piston is at the top dead center and this valve is trying to open, this valve may hit the piston head in this case, okay, in case of a smaller clearance body. So we have to open it actually when the piston is away from the top dead center a little bit. And also it allows, as we said, more air to the engine when we open the intake valve before the top dead center. And the exhaust valve closes after the top dead center to make sure all of the exhaust gases has left the engine. Okay. Here is the pressure. Almost the pressure is the big pressure is at the top dead center. Then we can have the expansion stroke. You can see here the intake valve open before the top dead center, and the exhaust valve close after the top dead center. And this period we call it the overlap period. Then we have this is the intake stroke, and when the intake valve is opening and the closing is just shown here in this diagram. Here is the variation of the volume while piston is moving up and down. The volume actually is changing between the minimum volume, which is the clearance volume, which actually is the minimum volume when the piston is at the top dead center, and the maximum volume, which is the cylinder volume, stroke plus clearance volume, displacement plus clearance volume, which is occur when the piston is at the bottom dead center, and it is just fluctuating this way. There is also a very important point, which is the ignition time, when we should ignite the fuel plus air. In some cases, if we need the pressure to build up early at higher engine speed, in this case, we have to little advance the point at which we should have the spark. Because at high engine speed, the combustion just need a little bit some time to start. So we try to advance the spark to make sure actually the combustion has already taken place at the correct time, to have the peak pressure when the piston is very close to the top dead center. If we delay the spark, that means actually the peak pressure will be delayed during the expansion stroke, and already during the expansion stroke the piston is moving down and the pressure is reduced. So the peak pressure will be reduced if we delay the spark, okay, and the power of the engine will be reduced. And also if we excessively initiated the spark early, that means actually the peak pressure will be before the top dead center, and in this case part of the power will be lost during the compression stroke. So we need to make sure that we correctly spark at the correct time in order to have the peak pressure very close to the top dead center. Then we can benefit all of this pressure in the expansion stroke. We call it actually the maximum braking torque, which we obtain actually at the perfect ignition time. This is one of the parameters for one of the specs of the car. He give you actually the maximum braking torque. This maximum braking torque is at the optimum spark at a given speed. Okay. If we have at higher speed, that means we need to advance the spark a little bit. Actually, make the spark advanced while the piston in the compression stroke, to have time in order to make sure that the peak pressure is very close to the top dead center. And this is also the spark timing for the compression ignition. There's a difference between compression ignition and the gasoline for the 4-stroke is that we have self-ignition. Here in gasoline engine, we have a spark is initiated during the compression stroke. Here, spark is initiated during the compression stroke. But actually, in case of gasoline, we'll have self-ignition that usually occurs few degrees actually before the top dead center. So we have injection of the fuel first. Fuel injection start before the top dead center, and fuel injection close just a few degrees after the top dead center. And the combustion usually starts before the top dead center. Then the pressure is raising, and then we can have the expansion stroke. We have a period here, Shabab, in case of diesel engine, we call it the ignition delay period. Fuel is injected, but the combustion does not start at the same time. Just it needs some time to mix with air, this fuel to mix with air, then the combustion can be initiated. The period from the start of injection to the start of combustion, we call it the ignition delay period in the case of diesel engine. You can look here also from this video when the valve is opening and closing. You can see an animation video of this. This is the 2-stroke Shabab, in which we have only one cycle. The cycle is completed in only one revolution. Here, the cycle is completed in 2 revolutions of the crankshaft. Here, it is only 1 revolution. Just I'm writing here, yani 2 circles just to show actually the different points, the different timing diagram, but only we have the cycle is completed in only one revolution. So here, starting from the top dead center, while the compression stroke, the fuel injection will start. This is for diesel engine شباب. Fuel injection will start before the top dead center, and it will close after the top dead center. Then we should have the combustion has started. Then we can have the expansion stroke. While the piston is moving down in the two-stroke, it will uncover the exhaust port, so the exhaust will start at the end of the expansion stroke. And also at the end of the expansion stroke, the transfer port or the intake port will be opening to have air plus fuel inside the cylinder, to have a scavenging of the exhaust gases. And the transfer port will be closing at the beginning of the compression stroke. We call it the suction part. And then the exhaust port, the piston is moving up, it will cover actually the exhaust port, and it will compress the fuel plus air in this case during what we call the compression stroke. And at the end of compression, we should have the fuel injection and then combustion. So this is the Shabab, the valve timing diagram for a two-stroke engine. So inshallah, I will be asking you actually, maybe in your quiz or something, this is a very important diagram that you should keep in mind. And I may ask you actually to upload the valve timing diagram, either 4-stroke or 2-stroke, either gasoline or diesel engine in this case. Okay, so that's enough for today. So see you inshallah next time.